Apakah suara saya terdengar?
Dengar, Bu.
Hello guys, can you hear me?
Yeah, hello, Dr. Atsushi, clearly?
Yeah,
Yeah,
I can hear you clearly. Yeah, thank you very much for inviting me to present my activities. Thank you very much.
thank you.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRAIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, research organization for governance, economy, and community welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with two main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs, tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology practices and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Pusat Teknologi Elektronika adalah instansi pemerintah di bawah naungan Badan Riset dan Inovasi Nasional yang memiliki tugas dan fungsi melaksanakan pengkajian dan penerapan di bidang teknologi elektronika, instrumentasi, dan telekomunikasi, serta penyiapan bahan rumusan kebijakan teknologi elektronika. Pusat Teknologi Elektronika berada di kawasan Puspiptek, Tangerang Selatan. Pusat Teknologi Elektronika dilengkapi dengan beberapa fasilitas laboratorium pengembangan dan pengujian, Laboratorium Advanced Network Protocol. Laboratorium ini melakukan pengembangan di bidang protokol jaringan dan aplikasi multimedia. Laboratorium Fotonika. Laboratorium ini melakukan pengembangan di bidang jaringan fiber optik dan light fidelity. Laboratorium multi
Okay. Ladies and gentlemen, thank you for joining our webinar. We will commence shortly. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and may peace be upon us all. Welcome to SISTEM, sharing Ilmiah Sains dan Teknologi Elektronika serta Manfaatnya, Volume 5, Current and Future Prospects of Optical Technologies for Automobile Applications. I'm Ilma Darujatin. I'll be the MC for today's webinar. It is an honor to me to inform you that among us here, we have Distinguished Head of Research Organization for Electronics Informatics BRIN, Dr. Eng Budi Prawara, Distinguished Head of Research Center for Electronics, Mr. Yusuf Nur Wijayanto, PhD, Distinguished Guest Speaker, Dr. Atsushi Kanno, and respected moderator, Mr. Vito Wigunanto Herminawan, SSIMN. Ladies and gentlemen, please allow me first to read the agenda for today. The first agenda is the opening session. The second is online seminar session led by our moderator. And last but not least is the closing session. Ladies and gentlemen, also please allow me to read rule of conduct for this webinar. Participants are expected not to interrupt the speaker's presentation. Please write any questions you have in the chat box or visit the link that will be embedded in the chat box. You can also access the attendance list and download certificates and materials using the same link. Ladies and gentlemen, we are now in the opening session. Without further ado, I would like to invite Mr. Yusuf Nur Wijayanto, PhD, Head of Research Center for Electronics BRIN, to deliver his welcoming remarks. Mr. Yusuf, you now have the floor.
Okay, thank you very much, Ms. Ilma. Before that, I would like to, dear distinguished guest, Dr. Budi Prawara, as head of the Research Organization for Electronics and Informatics BRIN, and then dear distinguished speaker, Professor Atsushi Kanno from Nagoya Institute of Technology, Japan. Konnichiwa, Prof. Hopefully you are fine in there. Okay, good afternoon to all participants in India. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, ya. May Allah give bless and mercy to and also healthy condition to us always. In here, I would like to give introduction relating our agendas today. Our agendas is called the SISTEM. SISTEM is the sharing ilmiah, sains and teknologi serta manfaatnya, or scientific sharing of science and technologies and also its application, which is a monthly webinar organized by Research Center for Electronics BRIN. Currently, we are holding the SISTEM Volume 5 and invite the special guest of the Professor Atsushi Kanno from Nagoya Institute of Technology, Japan. He will give a talk very interesting with the topics relating optical technologies for autonomous vehicle. As we know that currently autonomous vehicle is the main topic in the Research Organization for Electronics and Informatics in BRIN. Today, the participants almost from Indonesia, and especially researcher from the BRIN. However, some of them may come from the abroad. So I believe this webinar is very useful for us to create synergy and collaboration in the near future. And then I would like thanks to Professor Kanno for your important talk today, and hopefully we can create collaboration in the future by research together and sending our young researcher to your lab in the future. I would like thanks to also also to Dr. Budi Prawara, who is the attending in this webinar, and please to open our webinar today. Thanks to all participants, and please take the advantage of our webinar today. Last but not least, please enjoy our webinar today. And I just say the yoroshiku onegaishimasu, Professor Kano-san, Kano-sensei, and arigatou gozaimasu. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. We would like to thank Mr. Yusuf Nur Wijayanto, PhD, for the welcoming remarks. Now, ladies and gentlemen, we are now going to listen to Dr. Eng Budi Prawara, Head of Research Organization for Electronics and Informatics BRIN. Mr. Budi, time is now all yours.
Yeah, thank you, Ms. Ilma. So could you hear my voice?
Clearly, sir.
Okay. Excellency, Professor Atsushi Kano as our guest speaker today, distinguished participant of this webinar, current and future prospect of optical technology for automobile applications. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Konnichiwa, Sensei. I am chairman of Research Organization for Electronics and Informatics National Research and Innovation Agency, or BRIN Indonesia. As we know, BRIN is a new research institute in Indonesia, which was integration from several previous institutions such as LIPI, or Indonesian Institute of Sciences, BPPT, our national agency for assessment and implementation of technology, LAPAN, our national space agency, and BATAN, our nuclear agency, and some research division in some of ministry. Now, BRIN is the only one of a government research institute in Indonesia. We have 15,000 researchers, Professor Kano, and we also integrate our infrastructure and also for budgeting, and we have open platform, so we open the utilization of our infrastructure not only for our BRIN researchers, but also for external researchers, for example, from university and industry. In our research organizations, as Pak Yusuf mentioned before, that we have one of focus program on autonomous vehicle, namely autonomous system for electric vehicles. And now we do some research and innovation on the system of the electric vehicle and autonomous, and also some of supporting systems such as sensing and communication system to provide safety and security for our vehicles. Several technologies are used in here, especially using optical technology such as LIDAR and visible light communications. And based on this, our agenda today, through the case talk from Professor Kano from Nagoya Institute of Technology, is very important for us to elaboration furthermore our research activities. We do hope in further we can also create some collaboration and synergy with Nagoya Institute of Technology. I would like to thank you to Professor Kano for your sharing and talk today. Thanks also to all participants, and please take the advantage of the discussions. Finally, thanks to organizer from Research Center for Electronics for organizing this webinar. Stay healthy always for all everyone. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Thank you very
warahmatullahi
much.
wabarakatuh. We would like to thank Dr. Eng Budi Prawara for the opening remarks. Thank you. Ladies and gentlemen, this time before we go to the main session, we will take some photos together. So please activate your camera on your application, on your Zoom application. And I would like to invite our IT team to assist in taking pictures. I'm going to count from 1 to 3 and please be ready. Again, please activate your camera on your Zoom application. Okay. Are you ready all? Okay, please pause for the shot. I'm gonna count from 1 to 3. 1, 2, 3. Please, IT team, start to taking pictures. Okay, please kindly wait. We are still taking pictures. Okay, we've done taking pictures. Thank you for your all attentions. Okay, ladies and gentlemen, now we have come to our main agenda, the seminar session. All presentation and discussion will be moderated by our moderator, Mr. Vito Wigunanto Herminawan, SSA MEng. Allow me to read his short biodata. Mr. Vito Wigunanto Herminawan, SSEMEng, is a senior engineer at Research Center for Electronics. He has extensive engineering experience in navigation electronic system, charging station electronic system, battery-based electric motorized vehicles, smart cards, and telecommunications. He has granted some patents related to his researches that are registered in Indonesia. After completing his undergraduate studies in the field of electronics and instrumentation at Gajah Mada University, Indonesia, he continued his master's studies in information science at Nara Institute of Science and Technology, Japan, and has completed the program in 2020. Ladies and gentlemen, let's welcome our moderator, Mr. Vito Wigunanto Herminawan.
Thank you for your kind introduction, Ms. Ilma. Ladies and gentlemen, my name is Vito Wigunanto, the moderator of today's seminar. I'm very happy to see you here and welcome all of you to System Volume 5. Today's seminar is about current and future prospect of optical technologies for automobile application. Ladies and gentlemen, our speaker today is Professor Atsushi Kano. Konnichiwa, Kano Sensei.
Yeah, so good afternoon, everyone. Thank you,
Good
Vito-san.
afternoon, Sensei. Let me to read the biodata. Professor Atsushi Kano, he is a professor in Center for Future Communication System, Department of Electrical and Mechanical Engineering, Nagoya Institute of Technology, Japan. He obtained Master and PhD at Tsukuba of University in the field of physics. He got some grant and awards. The ones are the first prize ITU Kaleidoscope 2015 Best Paper Award, and so many publications and books. The ones are wireless signal encapsulation in a seamless fiber millimeter wave system in 2019. 2019, yes. During 2006 until 2022, he joined the NICT, the National Institute of Information and Communication Technology, Tokyo, Japan, where he is the director of Optical Access Technology Laboratory, and now he is executive researcher in there. His interests, his research interests include optical communication in vehicle network, microwave photonic, radio for fiber, millimeter wave and terahertz wireless communication, millimeter wave radar, high-speed optical modulation device, and electromagnetic imaging. He is a member of the IEICE, Institute of Electronic Information and Communication Engineers, Japan Society of Applied Physics, Laser Society of Japan, member of IEEE, and Society of Photo Optical Instrumentation Engineering.
Okay, before the presentation starts, let me tell you how the presentation will go. On the first, Kano Sensei will be invited to present the material around 25 minutes. After that, there will be a Q&A session followed by a conclusion. We hope that you will take advantage of that opportunity to find out more. So we will get right on with it and start the presentation from Kano Sensei. Kano Sensei, can you share your screen?
Yes, thank you, Tosan. Okay,
Yeah.
I will share. Okay.
Okay, this floor is yours.
Yeah, thank you very much for your kind introduction for me. And good afternoon, everyone. So I'm Atsushi Kano of Nagoya Institute of Technology. So I'm very honored to to present our recent activities in the distinguished researchers, engineers for the BRIN. Okay, so thank you very much. And first, I'd like to show the outline of the talk, today's talk. So the title of this talk is the current and future prospects of optical technologies for automobile applications. So this is the outline of my talk. First, I will show and I'd like to talk on the autonomous driving cars for the level 5, that is the completely autonomous driving systems. And to realize this autonomous driving, we have to develop the newly in-vehicle networks, such as automotive Ethernet systems and the other technologies. And of course, this technology can be delivered to the other fields, such as the future optical access network or the data center network system and so on. And summarize my talk after that. Okay, so let me introduce myself first. So I'm Atsushi Kano, this professor of the NITEC. We call it NITEC. This is Nagoya Institute of Technology. Here, NITEC or the Nagoya Tech. So I'm also the executive researcher of the National Institute of Information and Communication Technology. So my expertise is already introduced the optical fiber communications and the convergence technology between radio. Radio, that means the microwave, or millimeter wave, and terahertz waves, and optical fiber communication systems. So actually, the Dr. Vijayanto was a colleague in NICT about 7 years ago. Yes. So my expertise and his expertise is just what the high-speed optical modulation or the modulator technology. This is a very important technology to realize the 6G and 7G mobile systems. So, but today is just focusing on the automotive Ethernet or the automotive optical network technologies. So as you know, this autonomous driving is very, very important application to avoid the traffic crash, the traffic jams, and the other solutions. To realize the sustainable development goals defined by the United Nations. So the reduction of the carbon footprint is very important. So I think one of the important technology to reduce the carbon footprint is autonomous systems, configuring the autonomous systems. Actually, the autonomous driving and the autonomous car is one of the key technology to realize and to get the goal of the SDGs. So as you may know, the autonomous driving was focused on the first of the military application. So in 2004, this is 18 years ago, the DARPA, this defense, the research institute in US has called for the challenge on the autonomous driving with the 240 kilometer in desert or the off-road courses in 2004 and 2005. Actually, in 2004, this is the first grand challenge in DARPA. the no winners at that time. In 240 kilometers in Mojave Desert is located in near the California and Nevada states. So, but in 2005, the 212 kilometer off-road courses near this Mojave Desert, they have six group had completely run the very difficult course without any operation from outside of the car. That's the autonomous driving can achieve the 220 kilometer runs with around 6 hours. In 2007, the urban challenges that emulated to the urban metropolitan area in the George Air Force Base. This is located in the California. This urban challenges, Carnegie Mellon University group won with the run time of over 4 hours in 96 kilometers. So this is just a good result to realize the autonomous driving in near future in commercial applications. So of course, as you know, so the autonomous driving has the many stages to realize the complete autonomous driving with the SAN regulated level 5. So actually, at this time, the Volkswagen, BMW, Toyota, Subaru has completely finished on the level 3 autonomous driving. Level 3, that means the vehicle conducts some part of the driving without driver's engagement and the monitoring driver engagement. That means halfly realized by the autonomous driving in specific conditions. I think the Tesla US is one of the front runner to realize this autonomous driving. But even Tesla, the level 4 autonomous driving is not achieved yet. Level 4 is that people can drive and monitor the driving environment in themselves, but has certain environmental limitations exist. That means Tesla's autonomous autopilot technology can drive the highways autonomously, but in the dense urban area, it is a little bit difficult at this time. So in Japan, the 2023, the Toyota, Subaru, Nissan, Honda will try to realize the level 4 driving in real urban situations. This is in the Yokohama area. Now in Japanese government discussing on the level 5 autonomous driving after 2027 with the legal issues. So to realize this autonomous driving, so the automotive communication system, that means the in-vehicle communication system is very important because the many sensors, many cameras, radars, LIDARs should be connected to the in-vehicle networks. This is the current technologies. We have the many technologies even this era. The LIN communication systems is with a one-wire connection bus topology that is connected to the powered mirror, powered seat, and the heaters. Of course, the LIN is a very small data rate. It's less than 20 kilobps. So the CAN bus is configured with a two-wire communication system. Is commonly used for, of course, the automotive technology, and the other technologies of other solution is for the smart factories. CAN is very commonly used on this area. In automotive system, the CAN is connected. CAN is used as the anti-skid braking systems, the powertrain control, engine control, something like that. But typically, CAN bus has a capacity of about 1 megabps. Even the newly developed CAN FD bus system, even this system to 8 megabps, 8 megabits per second is limited. Now this Ethernet technology is delivered from the home and the data center technology to the automotive technology. So, but now this Ethernet, one automotive Ethernet system is just 100 megabps, so-called 100 megabase T1 technology with the unshielded twist pair. That's a two-wire systems. But yeah, for the autonomous driving, the capacity of the communication technology is insufficient to realize the many sensor recipients. But the automotive in Pukul network, we have the many issues. So one of the big issues is that this automotive technology, the automotive system requires a high operational temperature range. Almost all the devices should operate and they should drive with the temperature range from minus 40 degrees to 105 degrees. This is a very tough conditions. Of course, in the eye safety is very important because the engineers in the the car factory cannot wear this laser goggle or something like that. So the lasers in the automotive system should be less than 1 milliwatt. And of course, controller, the autonomous vehicle communication controller may and should turn off the laser if the connector is disconnected. This is a very important function, the features. And of course, the lifetime of the devices is also important. So at least 30,000 hours operation and the lifetime is indispensable because this is correspond to the 20 years lifetime and the 4-hour operation per day in every year. And moreover, the aluminum is the aluminum has a very not aluminum content of the devices should be reduced because the aluminum is should be lasted by this type of the hard and tough condition. So almost all the devices in the lasers and the other CMOS or the silicon technology should remove the aluminum content on the semiconductor systems. So to realize this, the high-speed optical technology in automotive systems, MOST is one of the promising solutions. That one of the solutions to for automotive infotainment backbone. This MOST technology with the optical system has already installed in the Toyota Prius or the other cars. I think the 100, 150 types of car in the worldwide, the most has been already installed with plastic optical fibers. So this plastic optical fiber is very used and for the audio communication technology, so-called SBTIF, the optical link, toslink or something like that. So this optical fiber communication to deliver the digital optical system, the audio system from the Blu-ray player or the PlayStation 5 to the the audio visual amplifier or something like that. So this technology is very useful. So because this step index plastic optical fiber with has a very large core diameter of about 1 millimeter. So we can easily to bend this type of the fibers. But of course, it is very large core fiber, and it has the large loss and the large interference of the optical signal at the receiver end. So this SBTIF or this type of the MOST technology has a limited with the transmission speed up to 100 megabps. But this plastic optical fiber technology is can be used for the the network technology in industrial conditions, the situations. Actually, almost all the industry has switched to the factory automations. So-called the one of the smart factory has been developed in the many areas, of course, including the Indonesia. So this is just the example of the GDPs from the IMF. So actually, this red dot line is the empirical borderline of the complete factory automation installations. Actually, in Japan, this type of the factory automation was rapidly developed and installed when the GDP per capita was reached to the US 10,000 US dollars. Let's say in Japan, that reached in the 1981. Okay, this is the as look on the GDP growth in years with the Southeast Asia. So Malaysia, China had already achieved in 10,000 US dollar per capita. So actually, the Malaysia, China has already started to realize the smart factory automation, that's the factory automation in the system. Thailand, Indonesia, Vietnam is rapidly growth on the GDP and the rapidly growth and rapidly installed in the factory automation as a smart industry. But in industry 4.0, so suggested by the Japanese, even in this industry 4.0 era, the small factories should be the hand-based or the manufacturer-based systems. So this is a well-known vision of the industry 4.0. This is the automated driving, automated control of in the line of the factory to develop some devices or something like that. But actually, the small factories, we have to develop some devices and products by our hands. But this we have to develop. We have to switch to this handmade factory to the automated factories. But in that case, the IoT communication in industry should have the features of anti-dust features and easy connections. In that case, the plastic optical fiber is one of the promising solutions because in the dust condition in living atmosphere, I'm sorry, this is just in Japanese. This is size of the house dust with 1 nanometer, 0.01 micrometer to the 100 micrometer. So the core size of the single mode optical fiber is around 10 microns. So if the type of the many dust is the size of the many dust has greater than 10 micron. So if we just connect and disconnect in dusty condition, we cannot communicate in this single mode optical fiber due to the insertion of the dust or something like that. So we have to increase the core diameter to install this type of the small factories or to realize a smart factory in small handmade factories. So as I mentioned, the step index plastic optical fiber has very large core diameter with 1 millimeter. But the speed of the communication speed is limited, is less than 100 megabps. So we can use the 15 micron core diameter multimode fibers, so-called GI50 or the OM3, OM4. So this type of the optical fiber is already commonly used for the data centers in the 10 gigabps link or the 20 gigabps link. So in that case, we can easily use this type of the 15 micron core diameter optical fibers. But as I mentioned, the step into plastic optical fiber has a great advantage of the large core, but narrow boundaries. But at that time, the Spanish company is provided for the 1 gigabps link with this type of step index plastic optical fiber with LED and photodiodes. So actually, this technology is designed and produced to the automotive Ethernet in the car at this time. So, and already this technology is already standardized in IEEE 802.3BB, that's a gigabit Ethernet for plastic optical fiber. So, but this KT Pop is a Spanish company. The professional said this is a limited. That's a 1 gigabit is just a limit for use of the step index plastic optical fiber. But for the more high capacity in vehicle networks, we have to use the more narrower core diameter optical fiber. So actually, the next generation of automotive Ethernet should be configured with the zonal network. So here is today is just the bus-based, the bus topology communication system. There's a devices or the ECU or something like that. So, but in the future and the near future, we have to switch to the bus topology to the ring or star topologies with the zonal gateways based on the Ethernet systems. Okay, so this is one of the system I just shown. This is zonal switches is located in the side or the front or rear ear. So in the front zone switch is connected to the high-speed camera, LIDAR, time of flight sensors, radar or something like that. In the left-hand side, the ultrasound proximity sensor or something like that is connected. Of course, this zonal switch is connected to the ECU and the GPU for the autonomous driving. So this type of the Ethernet technology is now discussing in the IEEE 802.3CZ or 3.3D age in multi-gigabit optical automotive Ethernet systems. So for the multi-gigabit throughput to realize, so we have to use the 15 micrometer core optical fiber, so-called the multi-mode optical fibers, with a 40 meter transmission capability with 4 inline connectors. This is a requirement from the optical car manufacturers. So the target throughput of this standardization is 2.5 gigabit, 5 gigabit, 10, 25, and finally 50 gigabps. So because but the 50 gigabps is indispensable or not? So I think the 50 gigabits per second is good enough capacity at this time. But I think the next generation, that means the coming 5 years, the 50 gigabps is not enough to connect to the new generation sensors. Actually, just with the examples of the required capacity of the camera for the advanced driver assistance systems. So this resolution of the horizontal vertical resolution is just a 4K with 30 frames per second or 60 frames per second. For the 4K 60 frames per second, the full color camera provides 12 gigabps. If we use the stereo camera with the 4K, of course the capacity will be doubled with 20 gigabps. If we use this type of the anti-collision avoidance camera system with the front camera, rear camera, side cameras, so so it requires 60 gigabps or 80 gigabps. So to realize to R&D, this type of the R&D, we have the Nagoya Institute of Technology established Center for Future Communication Research. This is the mission scope is the contribution to the society regarding high reliability of automotive and mobile communication systems, and particularly and especially for automotive, the basic research, standardization, and the test house. Actually, this research center has established in last year, and this next year we will open the test house facilities in this Nagoya Institute of Technology. So why Nagoya? Nagoya is a very good city and central city for automotive industries. Then in the Toyota, we have the Nagoya is just a central city for the industrial in the Tokai area at this time. So in the Tokai area, we have the many big manufacturers for the automotive system. Toyota headquarters is located in Toyota City near Nagoya. Denso, Aishin is just the automotive vendors, big automotive vendor for the Toyota, Nissan, and so on. And the Mitsubishi Motors has the good design, big design center, the technology center in the Okazaki City is just next of the Nagoya City. And as you may know, the Yamaha Motors is located in the Shizuoka area, the Hamamatsu area. This is 50 kilometers far from the Nagoya. So we can easily to access the Yamaha Motors. We just discuss on that. Okay, so the aim of the mission of the Center of the Future Communication Research is, so we have to develop the automotive technology in automotive optical Ethernet and electrical Ethernet systems. So here, we provide a test house to realize the closed and open strategy to deliver the commercialization, standardization to the international market, with the collaboration with the automotive vendors and the automotive industries. So we have the 7 divisions in this research center: wired communication in optical fiber solution, and wired communication in 2-wire copper wire solution, electromagnetic compatibility, wireless communications, quality of service, and based on the software-defined network or the TS and time-sensitive network, and car security and software-defined networks. So we have the many staff at this time. So the EMC and the communication QoS and security division, the wireless communication division, and the wired communication divisions. Okay, so I just speak here. So this is just an example of our test facilities. We have the radio anechoic chamber to test the EMC test or the EMI test for the harness in the car or something like that. And in the optical technology test set and the optical technology equipment and L2 layer 2 or layer 3 test by the QoS or the TSN test set has already prepared. In next year, we will open the facilities to the industries and to the commercial markets. Okay, this is one of the, so this is just an example of our R&D in optical domain. So we just use the MIMO technology delivered from the 5G mobile, the 6G mobile technology in the multimodal fiber to realize the high capacity and high speed automotive Ethernet technologies. So this is just the 3x3 MIMO technologies to realize the 10 gigabps, 20 gigabps, and 50 gigabps systems. And the other technology is the radio relay link inside the vehicles. So millimeter wave signal, this is a 5G mobile signal, cannot penetrate to the inside the car because the car has a millimeter shielded, shielded by the metal plate. So it's not so easy to deliver the signal in the glove box or the other, how to say, the passenger seat or something like that. In that case, so some kind of the radio over fiber or the millimeter wave radio relay link system is a promising solution to deliver the 5G or 6G signal deliver from the outside to the inside the cars. This is collaborated with Yazaki Corporation. It's a very big manufacturer in the harness. This is, I think, Yazaki Corporation is one of the biggest harness company in automotive systems. And of course, the optical technology is, of course, it is used for the communication and of course in the sensing technologies. So LIDAR is a very promising solution to detect the outside the car environment. But the breakthrough of the phase array of the electrical beam scanning is indispensable. Actually, at this time, the Bell array or the Vision Mini is just based on the MEMS or the 3D plus LiDAR system is already developed and commercialized. But it's a little bit difficult to realize the low cost and low price, how to say, the LiDAR system at this time. And we have the many competitors in the academia and industries. So that's why. So actually, our laboratory, that means our Center of Future Communication Research and our Kano laboratory is this LiDAR is out of scope. But we have to develop the part of the LiDAR technology, the simultaneous ranging with the communication link in the millimeter wave terahertz system or the optical systems. So we can easily to communicate. We can easily to connect the millimeter wave communication system with the optical fiber technologies, so-called radio fibers. So radio fiber is a promising solution to generate the high frequency radio signal generation and detection to directly capture and to directly receive to the optical fiber systems. So actually, this is one of the results from our NICT work. So actually, the millimeter wave and terahertz system can be tested by the radio over fiber equipment with the 90 gigabps in 90 gigahertz or 100 gigahertz. That is a promising solution to the 6G or 7G mobile communication systems. And the application of this millimeter wave technology or terahertz technology connected to the optical fiber technology is the fixed wireless system in network. So actually, the fixed wireless system is a promising solution to connect the access network without optical fibers. Actually, in Indonesia, Malaysia, Thailand, of course in Japan, some area cannot be in some area we cannot deploy the optical fiber due to the cost issue or the geographical issues. So in that case, we have to use the microwave communication link as fixed links. But the microwave link has a very small capacity, less than 100 megabps. So the many guys is just focusing on the millimeter wave fixed wireless systems, fixed access wireless access systems to deliver the 10 gigabps or 20 gigabps link in radio communication system. But in the millimeter wave, the signal has been affected by the weather conditions. Of course, in millimeter wave signal has largely attenuated by the rain or the large humidity condition, and some poles settled in the the radio equipment. If the strong wind is incoming in the pole, the pole is vibrated, so the received signal is very small. So we have to monitor this type of the spatial information, including the weather condition, to predict how to generate the millimeter wave signal to deliver the communication signal to the air or to the remote site. So actually, Nagoya Tech has received the commission research for beyond 5G technologies from the NICT Japan to realize this type of the software-defined network-based the radio controlled by optical networks. Okay. So I'm sorry, the time is limited. So I'd like to summarize my talk. So this is just a brief introduction of automotive technology outlook for current and the future prospect. for realization of the real level 5 autonomous driving cars. Of course, the R&D on the broadband in vehicle network based on the optical system is very important. And to check and to evaluate this type of the network, we have to prepare the test house solutions, and we have to operate this test house to open the vendors and academia from the viewpoint of open innovations. And of course, this type of the converged technology of the optical system and the millimeter wave transfer system is a promising solution for realization of the ubiquitous network, anywhere, anytime, anybody can connect to the internet. Actually, this is just a brief introduction and a brief summary of my talk. But Naviatech will contribute this type of the technology to realize the future network in 2030s. That means the 6G network, and 2040s 7G network systems. Okay, I think it's good time. Okay, thank you very much for your kind introduction and the kind attention. Thank you very much, and terima kasih.
Yeah, thank you very much, Kano Sensei, for giving such informative and interesting presentation. I think that your research is close with our research group. For your information, under Research Center for Electronics, we have some laboratory such as EMC, electronic design, circuit and optoelectronic, and also PV, photovoltaic and devices, control, navigation sensing, embedded system, and advanced network protocol, and so on. So I think that participant will give us some question in this chat link. Okay.
Yeah. I just found that.
Yeah. Ladies and gentlemen, now are the time for the question and answer session. I will read the question from the chat box. If you want to ask directly, please raise hand. Okay, for the first one, I can see. Okay, just a moment. What's the okay? For the first question, okay. For the first question, is cell the best option of laser source for the system right now? SLAD or other type of laser diode? This is.
Yeah, thank you very much. So actually, at this time, the big cell, the vertical cavity surface electric laser system is a promising solution, because even in this automotive Ethernet system, we have to reduce the energy consumption. So the other type of the laser diodes, such as the DFB laser, has a large threshold current. So the big cell is with a threshold current less than several tens of milliampere is a promising solution. So, and the many manufacturers, so-called Philips Electronics and INEOS in US and the other finishers, and the VIS company in Germany has provided the high-speed big cell with 25 gigahertz operated big cell has been already developed and commercialized. So I think this is one of the solutions. But the SLED is, of course, one of the solutions, but the SLED with the high, the high modulation, if SLED has a high modulation bandwidth, I think this is a good solution to realize the automotive systems.
Okay.
Yes.
Okay. This okay, for the second question from Anonymous, in this network quality of service test, from your experience, which is standard that we may follow to provide a more robust in vehicle network?
Yes, so actually, so at this time, the QoS is very important in the automotive Ethernet system because we have to rank the how to say the information delivered in the network. So rank that means the how to say infotainment. The automotive Ethernet system have received of course there's some kind of sensor information and infotainment system. That's the entertainment systems. But for autonomous driving systems, the radar and the camera information is very, very important. In that case, we have to label the high rank as we have to label this type of the network. Sensor information has a high rank to deliver the system without any latencies. So in this case, we have to use that type of the TSN, time sensitive network, to be implemented as a QoS test. So actually, in Nagoya Tech, the Professor Ito is a professional of this type of the QoS management on the TSN network for automotives.
Okay. Yes. Okay. Thank you, Sensei, for your answer. I remember that you are mentioned about step index plastic optical fiber that transmission speed 100 Mbps, but in the most infotainment backbone up to 150 Mbps. So how to improve the speed?
Yes, so in the okay, so I just used such one.
Your presentation.
Yeah. Actually, most technology is just the on-off or the PAM4 based, PAM3 based technology to realize the 150 megabps in plastic optical fiber. To increase the capacity, we have to use some kind of the increase of the multi-level, not order of the multi-level. Yeah, actually the 32 array to say the pulse amplitude modulation is already installed in this 802.3 BV to generate and to realize 1 gigabps. But of course, how to say the linearity of the signal of the LED and the photodiode is very, very important to establish a link. At this time, the LED high-speed LED has a not so good linearity because the resonant cavity LED has a very, very broadband communication system, but the resonant cavity degrades the linearity of the LED. So this is the comprehensive solution. So we have to use so in that case, the 32 palm or the 64 palm or something like that is, I think, the limitation of the LED-based plastic optical fiber communication. But if we use a big cell, so we can increase the capacity of via the plastic optical fiber. But of course, I think less than 10 Gbps will be the limit to deliver the signal via the plastic optical fiber.
Okay. Okay, thank you, Sensei. Yes. Okay, for the next question from Sasono-san. I'm curious whenever plastic optical fiber possibility whenever the cars are tested in Indonesia. Cars are running more than 1,000 kilometers during long holidays.
Yeah. Actually, the plastic optical, the most technology, the plastic optical fiber has already tested with 30,000 hour test with a heat shock or something like that. I think plastic optical fiber is already tested with some system, and some cars in Indonesia has the most plastic optical fiber-based infotainment systems. But I'm sorry, I'm not sure which cars has imported from the Indonesia or developed in Indonesia.
Okay.
But I think the 1,000 kilometer is.
I mean, it is in tropical area.
Yeah.
1,000 kilometers more running.
Yeah.
Without stopping.
Yeah.
And what about the thermal condition? I wonder actually about if the POF will be melted.
Okay. So of course, this plastic optical fiber for automotive system has tested with the temperature range from -40 degrees to the 120 degrees.
105 only.
120 degrees.
120, because average temperature inside our cars is more than 100, not more than 200. So it is
really?
The limit temperature will be let the POF, the fiber, melted, I think so. So it is good also for the study in tropical area.
Yes, that is a very good point, I think. So, but actually at this time, plastic optical fiber or some kind of this type of the plastic optical fiber is just not a major solution for the next generation automotive Ethernet. As I mentioned, this 802.3CZ. I'm sorry, 3.3CZ is just a glass-based multimodal fiber should be installed with the 2.5 gigabit or multi-gigabit systems. I think the glass-based optical fiber, it has the good advantages on such kind of the 200 degrees high temperature condition or something like that, I think.
Okay, thank you, Professor.
Okay, thank you, Mr. Sasono. Okay. Yeah, we have two questions from the chat box in this room from Miss Bunga Meizia. Thank you for explanation, sir. I would like to ask you about this research in detail in the future. How will this research will be and how to develop it if it will be do it in Indonesia? I think previous question same like Sasono Sang question. So or maybe since I have another answer.
Yes, that is a similar answer I'd like to say. So actually, this type of tropical area condition is very, very important because half of the area in the worldwide is just tropical area or the very heated area. But in this area, we have to use we have to develop we have to use the car by the transporters. So I think we have to develop the higher temperature range optical devices or the electrical devices to install the car. And another important point is just vibrations. In the metropolitan area, such as in Tokyo or the New York, the road is very flat, but some area is very bumpy situation. So the vibration control or the anti-vibration of the harness or the connectors should be installed in the car.
Okay. Yep. Okay, for the next questions come from Mr. Taufik Ibal Ramdhani. I would like to ask question regarding the transmission in automobile. whether between V2V or V2I, it can be achieved using wireless communication. What the type of transmitter or receiver is good to implement massive MIMO technology? Let's talk about the MIMO.
Yes, I think very good questions. So, okay, so in my opinion, that we have to separate the wireless communication technology for VTV, vehicle to vehicle, and vehicle to infrastructures. So actually, V2I, the vehicle to infrastructure, should be used based on the mobile technology, so-called 5G or the 4G, so-called the cellular V2X communication systems. But in that case, so if we use the 28 gigahertz 5G millimeter wave signal as a CV cellular vehicle to infrastructure, we have to implement massive MIMO systems. But it's a little bit difficult. I think the sub-6 frequency range communication system should be implemented for the fast cellular V2X communications. But on the other hand, on the V2V, vehicle to vehicle communication systems, so for the trainary bus communication or the transportation system, I think the millimeter wave single carrier communication or the terrestrial wave single carrier connection is green now. Because the B2B communication for the trainary systems, trainary configuration, the distance between the vehicle is less than 5 meters. So very, very short range communication systems. In that case, simple and high capacity millimeter wave and the terrestrial communication system is more useful for that case, I think.
Okay, clear, Sanjay. Okay, that we have the next question from the question link, please. This one. Just a moment. From Mr. Merlin, any possibilities or experiences about the electrical to optical and optical to electrical converter in biomedical field, such as diagnostic or detection?
Yes, thank you very much. So actually the NICT has some project related on the biomedical sensing technology based on the optical fiber communication systems. One of the technologies and one of the solutions, this is collaborated with the Chiang Mai University, Thailand, and Khon Kaen University of Thailand, and NICT provided the antigen and antibody sensing chip in optical systems. So in that case, in this system, the laser technology is very important, and of course, there's some kind of the wavelength sweeper technology based on the EO modulator is very useful to realize a high-speed scanning of the antigen antibody silicon photonic chip or something like that. I think this is one of the important solutions, and the other solution is for the the confocal, the microscope with the biomedical the transmission intensity and phase simultaneously measurement technology. I think this the phase and amplitude image detection, we can easily to use the optical digital coherent optical fiber technology. I mean the high speed optical to electrical converter technology. So this for the biomedical field and the biomedical imaging technologies, I think the EO and OE is we can use this high speed and the broadband, the devices and technology and the converters to the field of the biomedical systems. I think Yeah, thank you very much.
Okay, thank you, Sensei. So yeah, this is possible to use the OEEO. Okay, this one we have the question. I'm glad to see. And thank you, Professor, for the interesting presentation. I'm glad to see you again. This is from Miss Hannah. My question, in your opinion, when the autonomous vehicle will be widely available in the road or market, replacing the conventional one, especially in the Japanese autonomous vehicles?
Yes, thank you, Hana-san, and I'm very glad to see you again. Yeah, so actually, so in metropolitan area or the public transportation system, the autonomous vehicle or the autonomous bus system should be installed and will be installed, because in Japan, the population ratio in the older guys increased and increased. So the number of the driver will be decreased. So this type of the city commuter or the transporter, that is such as the bus system, public bus transportation, should be controlled by the autonomous solutions. But in the, how to say, rural area, actually in Japan, we have the many rural areas. In the rural area, I think they're not so important because many guys have their own cars. So there has no public transportation bus systems. So in that case, they have to drive by themselves without any autonomous systems in these 20 years. But after the 2014 or 2015, so the autonomous car on the conventional car will be replaced by the autonomous car. But that's in metropolitan area will be rapidly replaced. But in the rural area, the speed of the replacement will be slow rather than metropolitan area, I think.
Okay.
Thank you, Prof. Hope see you again in the future.
Thank you.
Any other? Hana-san, you want to ask again?
I think enough. Thank you.
Okay. Okay, this we have a question. Maybe this is one from a young researcher. Thank you very much for your presentation, Professor Atsushikano. Is there any information about scholarship for master degree at NITEC?
Yeah, so I'm sorry, I have no information for the master degrees. Yeah, but we have made some scholarship. Of course, in Nagoya Tech has not a big university, because Nagoya Tech is just focusing on the Institute of Technology. So number of the students and number of staff is very small. In total, less than 6,000, including the bachelor student, master student, and doctor students. So so in that case, so I said the total budget of the university also small. So I think some kind of the scholarship we have, but I'm not sure this is focusing on the master course or the PhD course or not. So I will check later. Thank you very much.
Okay, good. Okay, yeah, maybe we hope on the future we can make a collaboration and send out the young researcher to NITEC.
Yeah, thank you very much.
This one, any other question? Maybe this one from AMC member. What I know is that electromagnetic signal can interfere with other devices in the vicinity. Related to MC, how does millimeter wave affect the vehicle? And is there a power standard for millimeter wave transmission?
Yes, thank you very much for the, okay, so the first questions. So this is just the Center for Future Communication Research. We just have the communication EMC divisions here. So under IEC standards organization has established for the EMC standard, the EMI test standards in TC47, I guess. So in that, the community and the community in our NITech is just test for the EMC design and the EMI electromagnetic immunity test to the harness in the car and to design the chip on the ECU and the board, PCB board in the ECU or something like that, like this. So, okay, so elements. So actually, in automotive Ethernet systems, so the EMI, the EMC is very, very important issue. So to say the 100 megabit Ethernet, so-called broader network, is the carefully designed for the anti-EMI systems. So for the lower frequency, less than the 1 gigahertz is very important. But in the millimeter wave systems, I think, of course, would be affected. But how to say the devices, such kind of ECU, GPU, and the communication chips is operated with less than 30 gigahertz, even in the very advanced system. So 60 gigahertz or 90 gigahertz, 80 gigahertz millimeter wave cannot affect that, I think. But some millimeter wave, such kind of 5G signal, may affect. So that's why the IEC or the other standardization bodies is just now discussing and researching this type of the effects from the microwave band to the millimeter wave band to the automotive EMC design, the EMI test, I think. And I'm sorry, I have no idea and I have no information on the power standard for the millimeter wave transmission. Doesn't power standard that mean the SAR or the coefficient or the other values?
Hello, Tinsi?
Yeah.
Okay. This is quite enough. I think it's clearly from your question. This timekeeper said me we only have 2 minutes left for this Q&A. Any other question for this season? Maybe we just have the question.
In the chat, I think I can find the new queue.
Okay, actually I have no question, but I have how to say the Dr. Budi Prawara already mentioned in here. He want to make some how to say to know more regarding the autonomous vehicle, especially in the specific area. As you know, in the all day you visit the Bandung area, I think, the LIPI, and you know our condition Indonesia with the tropical area and then the how to say the forest and then something like that. What do you think about this region? It can be what how to say, what is the best system communication in here for our country? As do you comment, please give us.
Yeah, we can answer. So thank you very much. So it's a little bit difficult to say that. So how to say for automotive systems?
Yes.
Actually, the concurrent system such as Ethernet, electrical Ethernet system is very mature and is already installed in the BMW car or something like that. So for other inside the in-vehicle communication system.
Mhm.
And for the V2X, vehicle to the infrastructure or something like that. So I think that for installation to the car, the cost of the installation is very important. So in that case, a cellular-based communication system should be implemented.
Okay.
But yeah, so in the Zoom chat, the new question has a similar question related on the security implementing the MIMO technologies in the autonomous vehicles. So yeah, this is very important question, the important issue. So this type of the massive MIMO technology is just the communicate with the beam-like systems. So how to say, such kind of the physical layer security can be established, can be realized by the beam-based communication systems. But in sub-6 and 4G, 4 gigahertz, 3 gigahertz microwave systems, it's a little bit difficult to keep the security or the preventing the information integrity or something like that. So how to say? So some kind of the higher level security should be installed for secure the passengers in the car. But I think this is similar. They have the similar issues on the cellular communication system, the mobile communication system. If so, we can easily to deliver this technology, the 3GPP or the 5G 6G technology to the automotive cellular V2X, I think.
Okay. Maybe this one, the last question from in this session. And just a basic question, how to the safety guarantee for using this technology in the future?
Yeah, so how to say, it's the little bit difficult question to answer that. So yeah, so how to guarantee the safety? This is of course some kind of the guarantee the quality of the device, the quality of the network can be guaranteed by the test or the certificate, and pass the certification, such as the quality certification or something, and the quality control or something like that. But for the passenger safety, of course, this is a very important issue in autonomous vehicles because due to because based on the engineering issues and legal issues. In the legal issues, that means which is responsible? Who is responsible when the car has crashed by autonomous systems? So yeah, actually in Japanese government, of course, I think the Indonesian government is just discussing on the legal issue to implement this autonomous vehicle in real situation, I think. Yeah, but actually, in Japanese government and I think in the worldwide, we have no answer at this time. We have to discuss with lawyers and of course the engineers and of course the politicians to consolidate some kind of the achievement and the deliverables to input to the new law or the new regulations.
Okay. Yeah, this okay, Sensei. Okay, Sensei, I'm sorry that time is over for Q&A session. Maybe that enough for us in this session. So we come to the end of this seminar. Before the closing seminar, I want to draw a conclusion from what the speaker said. In this webinar, Kano Sensei introduced the current technology and R&D for in-vehicle network, especially in the related technology for V2X, V2I, and V2V and sensor based on the optical and radio system. High speed, robustness, and resilience in ICT system are highly demanded to develop economic, science, and technology sustainable worldwide. So in the coming 2030, we will give 6G mobile and level 5 autonomous vehicle system to connect all the devices and system for cyber physical system based big data analysis. So however, to support the safety in autonomous vehicle, the current 100 Mbps, even though advanced 1 gigabit per second, the in-vehicle network is insufficient to receive the signal from high-resolution sensor such as LIDAR and camera, and also broadband in-vehicle network are required. Therefore, high-capacity in-vehicle network are now being developed in academia and industries. So the last, hopefully for the next, we can research collaboration, we can make research collaboration and send out young research to study in your lab to support this technology. Okay, ladies and gentlemen, in the last part, I would like to thanks to the speaker, Professor Atsushi Kano, for the interesting presentation, and all the participants for their active participation. Thank you for your kind cooperation, Kano Sensei. Nice to meet you. Arigato, otsukare-sama. Big applause for the speaker and all of you.
Thank you very much.
Thank you. We would like to
going
thank.
back to Miss Ilma.
Thank
Okay.
you.
Thank you. We would like to thank Mr. Vito Wigunanto Herminawan SSEMA for bringing us to a very productive session today. So, ladies and gentlemen, we are now in the closing session. Without further ado, I would like to invite Mr. Yusuf Nur Wijayanto, PhD, Head of Research Center for Electronics, to deliver closing remarks. Mr. Yusuf, time is now all yours.
Thank you very much. Thank you very much, Professor Kano Sensei, for your very interesting talk and maybe inspire for us, enlightenment for us for about the future technology. Actually, your presentation is related for our current project regarding the autonomous electrical vehicle. So currently we develop this project and we try to make some vehicle, and we try to give some good technology for the autonomous one. And I have some message from our chairman of the research organization, Dr. Budi Prawara. He hope to make a collaboration in the future and synergy, and we will try to deep discussion with you and your colleague in the Nagoya Institute of Technology. And hopefully for the participant from here, maybe the young researcher can also study in your laboratory. So if you have some information regarding scholarship, please inform us and we will try to apply. And also, the BRIN also have a scholarship also, maybe you can support for the study in Japan also. Thank you very much, Kano Sensei. Hopefully we can meet next year, I hope, hopefully. Okay, maybe I will back to Ms. Ilma, please. Thank you very much.
Okay, we would like to thank Mr. Yusuf Nur Wijayanto, PhD, for the closing remarks. Ladies and gentlemen, we would like to remind you again that the attendance or registration link is now available. We have embedded the link in the chat column. Please fill out the form completely so that later there will be no identity writing errors on the certificate. We will send the certificates to the registered emails. Ladies and gentlemen, this webinar is the end of a series of systems. On behalf of the committee in charge, we would like to express our apologies for the mistakes we made during the event. Thank you for your active participation today and have a great rest of your day. See you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much.
Thank you, everyone.
Thank you very much.
Thank you.
Thank you all.
Thank you very much.
Thank you very much.
Kano Sensei.
Yes,
あ
I'm here.
も
Yeah.
もしよろしければ、個人的に質問がありますが、電子メールとしてよろしいでしょうか。
はい、OK です。大丈夫です。
ありがとうございます。
Welcome. Yes.
よろしくお願いします。その説。
はい、Thank you very much.
失礼いたします。
Communication. Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and developments in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, imaging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as JOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Sinta 2 in Commander's Techprint accreditation system. There are 2 JET editions published online every year, and it provides open access to support global exchange of knowledge. All submissions in JET are accepted online, and every paper will be blindly reviewed by at least 2 peer reviewers. Most importantly, every submission is free of charge, and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone.